All right, hey y'all. So we've been working with functions and whether functions can be linear or nonlinear, or whether it's a function or not. Now we're moving into linear equation word problems, which we've done before, we've seen before, but we get to see it again in this unit, which means we can just solidify what we already know. So for some of y'all, this might be easy. For some of y'all, it's good you're seeing it again. Some of y'all be like, I already know this. Whatever. Stay tuned. Stay tuned. All right, so linear equation word problem. So we already know the equation of a line is written as y equals mx plus b. That's cool. We got that. We are so good with that. All right. The slope or the constant rate of change is your m. Y'all are so smart. And then the y-intercept, which is the same place where x is 0, is your b, right? Because remember, a y-intercept is a point on the y-axis, so your x is always 0. All right, now we have these two definitions we want to introduce. We are going to have a dependent variable. Sorry if my hand's in the way. A dependent variable, right? And a dependent variable is just a variable that depends on one or more other variables. Okay, so in y equals mx plus b, our dependent variable we're going to say is y. And we're saying that because whatever we plug in for x tells us what y is going to be, right? So y depends on x. It depends on what x is in order to determine itself, right? Our independent variable is our x, all right? So these are just terms you should know and be familiar with, right? So dependent variable, same thing as your y, same thing as your output. Remember, we're looking at inputs and outputs, all right? And so just as a reminder for some of our keywords for slope or keywords for y-intercept, some of y'all are real good with this. You're going to tell me, oh, per, each, every, for a. Sometimes it's like $6 for a something, right? Those are words we use that tell us, okay, this is slope. It's something I have to pay constantly. Not just one time, constantly. Keywords for y-intercept would be base cost or fee, / fee. Initial, it's like your starting value, right? Initial, starting value, initial fee, just fee in general. Those are all keywords for y-intercept. But you should also know that your slope is something that you have to pay for constantly. It's going to depend on, how many of something you're buying or you're paying for, etc. But y-intercept is initial value, right? It's your starting point. You pay that one time and then you don't have to worry about it again. All right, so for example, let's look at example 1. So Paula runs a bakery. She estimates that her base cost, look at that, base cost of rent and electricity is, is $250, right? The ingredients to bake each cake, okay, each cake is $4. Write an equation relating the total cost T to the number of cakes baked C. So don't let these letters confuse you, right? All they're going to do is take the place of y and x. Right? That's all they're doing. They're just taking the place of y and x. It's the same thing, but we got to decide which one's y, which one's x. Then answer, how many cakes did she bake if she spent $290? So we're going to define all our things. Okay? So our independent variable, right? We know it's the y. Oh, another keyword for y-intercept is total. It's usually your total. Not for y-intercept, sorry. Ignore me. So just for your y. So write an equation relating the total cost T to the number of cakes baked C. So her total cost depends on the number of cakes she bakes, right? So our dependent variable would be T, which is total cost. Same thing as y, right? T and with y in parentheses. Because total depends on the number of cakes, so it's dependent. Independent, the number of cakes she bakes. So that's C, which is the same thing as x. Don't let it confuse you, but you need to be able to see different variables and still relate it to y and x. It's important. Now we're going to define our slope and our y-intercept, which are just numbers. So we said the slope. Keywords is per, each, every, and 4a. It says each cake is $4, so I know that's the slope. Base cost is $250. I know that's the y-intercept. And we're used to writing an equation like this. y equals mx plus b. Plug in for m and b, right? Y equals 4x plus 250, right? We're doing the same thing, but instead of writing x and y, we're going to do c and t because that's the way the question wants us to write it. So I'll say t equals, because that's my plug in for y, 4c plus 250, right? So total cost equals $4 times the amount of number of cakes she bakes, plus that $250 that she has to pay for rent and electricity, right? And we're just looking at it for 1 month. That's why it's that one-time cost. So that's my equation, all right? So then answer, how many cakes did she bake if she spent $290? That's our equation. So she spent $290. I know I'm plugging in for either T or C, and C is cakes. We're trying to figure that out. So obviously, I'm going to plug in $290 for T and solve for C. All right. You can do the box method. You can do any method you like. It does not matter. I'm just going to do the regular way where I subtract 250. 40 equals 4C. Divide by 4 on both sides. C equals 10. That means if she spent $250, $290, she made 10 cakes. All right. You cannot do 290 divided by 4, right? You first have to subtract that 250, that starting cost. So that's your first example. Let's look at one more or two more. One you're going to try on your own. So let's look here. Sudozo Wash and Wax charges customers 75 cents per minute to wash a car. Write an equation that relates the total charge C to the amount of time T in minutes. So independent, dependent variable. Okay, so let me underline 75 cents per minute to wash a car. Write an equation that relates the total charge C to the amount of time T in minutes. So the total charge depends on the time it takes to wash your car, right? So C would be your dependent variable because it depends on time. Your independent variable is T, right? You could go do however many minutes, and that's going to be the cost. The cost is not going to, or the time is not going to depend on the cost. So your slope here, we said it's words with per, and I only have one number here. So 75 cents is my slope. But interesting enough, there's no y-intercept. So they don't charge no base cost. They're not saying you can pay $5 and then 75 cents per minute. They're just saying you paying 75 cents per minute. So there is no y-intercept. I don't have to worry about that. I'm put a little dash. So my equation, we would usually write it as y equals 0.75x plus 0 because there's no y-intercept. But I don't have to put plus 0 because it's just 0. So now I plug in for what my y and x are going to be. So my y is going to be C equals 0.75, and then my independent variable, which is x, is T. So the total cost equals 75 cents per time, the amount of minutes, right? Cool. I want you to try the next one by yourself, and then pause the video, do it by yourself, then watch the video so you got it right. All right. Her non-cell phone company charges $35 a month for phone service, plus $50 for each text message. How many text messages does her non send in a month if his bill was $52? So you see the word A, you also say each, and so you might think both of these are the slope, but remember you have to understand that the y-intercept is like an initial value, okay? So keep that in mind. So initial independent variable and dependent variable, it didn't give us other ones, so we should just say independent is x, dependent is y. If it doesn't give you the variables, that's what you can say. Don't worry about it. My slope. So this is where what I was saying comes into context. So $35 a month plus 50 cents for each text. So I have to pay, every month I have to pay $35 no matter what, no matter how many texts I sent. So that's going to be my initial value. That's going to be my y-intercept. And I know that 50 cents for each text is going to be my slope. So 0.50 and then 35 is my y-intercept. So my equation will look like y equals 0.50x plus 35. All right. The question said, how many text messages her non send in a month if his bill is $52? So his total was 52, right? So that has to go in y. So 52 equals 0.50x plus 35. Because we're trying to figure out how many text messages did he send? Sorry. So subtract 35 on both sides. Drew my river. So 17 equals 0.50x. Divide by 0.50. That cancels. X equals 34. So his bill was $52. That means he sent 34 text messages, y'all. Y'all, imagine having to pay $52 just to send 34 text messages. Who y'all gonna be texting? Nobody. All right, so y'all got that information. Go on to your independent practice. You got it. Did y'all see this? Sorry. Cool.